Hey everybody, hope you can hear me all right. Let me know if the audio isn't balanced or anything. As usual, just feel free to check in. We are live right now with our developer Microtalks that we are doing today, and this is it's really sort of just a casual us talking about a few aspects of the game, a few, totally different topics that we've got lined up here. And hopefully these should be useful for, if you make games, if you're a developer, or if you're just interested in some of the, the behind-the-scenes stuff that we're working on and why we've made some of the decisions we had. I see we have a few viewers right now, so that's awesome. So I'm just here to introduce Joe Williams. He is he's in charge of all of our music in the game and has done a great job with that. But in addition to that, he's been doing a lot of work with the game's AI. So, and there's Keanu. You might be able to hear him in the background too. So I'll hand it over to him. And we'll do a little swap.
Good morning, everybody. I hope everybody's doing well today out there, staying safe, loving life. As Olivia said, I'm Joe Williams. I am the sound designer and musical score person on TTR. But I also work on the AI. So I am going to fire up a scene here in Unity, which is the game engine we use to develop the game. So I can talk to you guys a little bit about how the AI works. There are a lot of different kinds of AI, and obviously we don't have time. This is like a 12-minute talk, so I'm not going to be able to get into all of them. But there are things like finite state machines and behavior trees. The current AI we're using in the game right now is what's called a behavior tree, which basically means it's like a branching thing where basically when certain conditions are met, then the dogs will change state. So they'll go, oh, I'm thirsty, and then they'll bounce along the behavior tree to, I should go get a drink. But there are other kinds too. There's a kind called goal-oriented action planning, which is pretty cool. Unity actually has a really neat new set of tools for that coming out probably in the next year or so. And that's for really sophisticated AI where...
Sorry to interrupt. Let me just check something real quick with the stream.
Sure.
I'm worried that I actually stopped it. No, it should still be going. Okay, sorry.
Okay. Everything's fine. We're all fine here. How are you? So goal-oriented action planning is for pretty sophisticated AI where you want your AI to actually go out into sort of a plan, right? And think, well, what's going on in the world? And I'm trying to get a job, but there's some things stopping me from that. And make a plan based on what the AI thinks the world's going to do in the future. And that's more than we needed for this project, so we didn't do that. And there's even like learning machines, which is where you can actually train an AI by making it practice something over and over and over again and make it get smarter. Again, more than we needed for this project. So what we're doing for this project is called a utility AI. And basically what that is that we are creating a system where the AI basically weighs different values, and it says, well, which of these scores matters the most to me? So it's got like several different numbers that it's tracking in different conditions, and it's at any moment it can say, well, this is the thing that's most important to me, so I should go do this thing. And that's the kind of AI we're going to use. So there are kind of a few things that matter in a utility AI. One is basically the world information that the AI has. So like what kinds of things the AI can pay attention to and keep track of. The second thing is how that information is weighed. So what's important, what's more important, what's less important. And then how can pieces of information work together? So like I know that I'm thirsty and I know that there are some water bowls I can get to. But which water bowl is the best one? So is one further away? Does one have more water in it? Is one being guarded by a killer alien spaceship? So taking multiple pieces of information, weighing them all together and saying, well, which one of these is the best overall? Not just based on one thing, but based on all the information I have. So with that said, what I have in front of you today is a kind of little test bed for testing out our utility AI. And what I'd like to do for you is kind of play through it a little bit and talk to you about some of the different parts, and hopefully that'll be cool for everybody. If it gets not so cool, let me know in the chat and somebody will tell me. I'm a Gen Xer, so I don't really multitask at all or follow, how computers work. But let me just go ahead and pop up our dog AI, and then I can talk to you a little bit about what you're seeing on the screen here. Let me just drag a couple of quick things. Let's put that like that. Let's drag, let's drag this guy down here. And okay, so I'm going to go ahead and hit play here, and hopefully with a little luck you'll start to see some stuff happening. So let me just kind of talk you through what you're seeing first of all, and then we'll add some new things into the mix. So right now what you're seeing is 1, 2, 3, 4, 5, 6, 7, 8 dogs. So the little sort of half-sized yellowish cylinders are dogs. And there's also 3 little helper bots that are at work as well, these taller white ones. The little blue squares here are bowls of water. And this whitish thing in the corner here is essentially a sink where the little helper bots go to fill up their water. I've highlighted what are called gizmos, which are these fancy little things on the screen to show you some more detail about what the AI is doing. So for starters, all we have here is just some pathfinding. So pathfinding, for those of you who don't know, it's basically how an AI moves around a 2D or 3D space. These AI are using something called A prime or A star as their algorithm. Not that important to know really, but so these little green lines, right, are them making new paths to figure out where they should go next. So at its most basic, right, movement is a really important part of games, and so getting things to move around the way you want them to. These AI right now are sometimes moving randomly, but then sometimes, like if you follow this one heading over to the sink, this guy probably figured out he was out of water in his watering can, so he just filled it up, and now he's going to a little water bowl to refill it. And in a minute, I'll show you some of the underlying stuff that makes that part happen.
Joe, got a question.
Okay.
Somebody's asking what program is this? What are you using to make this AI with?
Okay, so the underlying tool, amazingly, the name just went right out of my head. What is it called? It is called, Apex, sorry. It actually does not exist anymore as a tool that you can purchase. The great news is that there's a GitHub, if you know what GitHub is, there's a repository for GitHub for the entire Apex library, which is what's the underlying stuff we're using. And you can just go to GitHub and grab all the Apex code and use it in your game. It's all written in C#, which is Unity's engine, or programming language. So yeah, so just find Apex AI on GitHub and grab it, and you can put it in your own Unity game and start making AIs like this. Okay, so I know I only have like 5 more minutes, so I'll keep going. Great question though. All right, so with all of that said, then let me just show you a little bit about what's going on with, and it looks like sometimes our little helpers get frozen, so I'm just gonna restart them. You'll notice that not all bugs change when you move from AI. So we have a bug in the AI right now that causes dogs to freeze. My current version of this, occasionally the helpers freeze, but we're gonna fix that, no problem. So what I'm going to do is select one of the dogs so that you can start to see a little more sophisticated view of what a dog is doing. So let me just turn on visuals. Okay, so now things are going to get a lot more wild looking. We've got one dog selected, and suddenly we have a lot more information to look at. So let me just scroll that down a little bit so you can see better. All right, so a bunch of things looking at here. So the dog we have selected, if you can see, it's this one I'm following with the mouse. There are a couple things I want you to notice right away. There's a white line that moves from that dog to any water bowl it's noticed. And the reason that's important is that one of the key things I told you earlier is that information about the world is really important to an AI, and knowing what it knows and how to evaluate it. And if we could just have the dogs know about all the water in the world, right? We could just say, well, they know where all the water bowls are, and then they can just go to one. But if we want a little more interesting AI, right, one with a little more subtlety to it, in the real world, a dog just doesn't know where all the water bowls are. It has to find them. And so our dog, over time, identifies water bowls, and the ones that it's identified in this little debug program we're running, you can see it adds a white line to them whenever it's found them. And so we can figure out which water bowls does this dog know about, and in this case there's 1, 2, 3, and then which ones doesn't it know about? Doesn't know about that one or these ones over in the corner. So that's the first thing to notice about what we can see here about the AI. The second thing is these crazy lines and numbers that are all over the place. So one of these is how much of the floor space, how much of the environment this dog knows about. So these little green dots that are everywhere on the floor, that's how much of the environment the dog has mapped out. So how much does it know about this overall space? These little green dots tell us that. And all the time it's kind of learning more. Eventually, if we left it running long enough, it'd probably learn the whole space. The red dots, the bigger ones, it's kind of regular like radar, if you want. And you'll notice that next to each one of these red dots, we'll get a little score. So the 5.8, 4.8, 6.5. So one of the other important things with running an AI, Kiana the dog has come over to start licking me, so if I stumble at all.
We had a combat saying the dog sounds a bit like their Roomba.
Yes, he's licking everything he can find. Okay, so these big red dots are basically like this dog's radar, and it's always trying to make up scores for where it should go next. And it's privileging places that it's never found before, but it's also privileging places that are further away from its current location. And the reason we did that is if the dog's traveling randomly, we kind of always want it to be exploring new space. And so, and I should mention that almost none of this is in the current AI. The current behavior tree AI is just a little more straightforward. It just tracks, well, is the dog hungry? Is the dog thirsty? But with this new version, we're trying to create one that's more advanced and can do some more interesting things. And so, again, so now you'll see this dog has made it up to the corner. It's learned some more about the space. It's continuing to give itself radar. And again, these red dots you see are the full range of what it can see and what it can kind of evaluate. And all the dogs are running that same thing. So if I click on different dogs, you'll see each one of them has its own radar to learn about the space and its own things that it cares about. So the dogs care about water bowls. This dog weirdly knows about the sink. I'll have to look into that. In theory, dogs should only care about things that matter to them, and the sink is not actually one of those. But anyway, so in theory, we could add anything to this environment and keep the dogs tracking it. So food bowls, water bowls, other dogs, which is kind of moves me to the last point I want to make before I wrap up, which is the next phase of this, beyond these kind of basic needs of the dogs, is that we want to give them some more personality and relationships to other dogs, and that's kind of the next phase of this, which is once we can feed them and water them and do all that stuff, how do we get them to understand their relationship to another dog, to have memories about that other dog? So if a dog attacks them or is really mean to them, how do they remember it later? And have those relationships hold on over time so that dogs have more interesting connections to one another and personalities as well. So all of that is built on top of the Apex stuff that we're doing for the kind of basic movement and kind of tracking of the environment. I have no idea how much time I have.
I don't know either, but you do have a few questions.
Okay, good. Go.
So someone's asking that, so once the AI learns the whole area,
Yeah.
The AI itself, so they'll remember that room forever, or will they not?
Yeah, currently they will remember this space for as long as eternity exists. Yeah.
Dogs have good memory.
In the current setup, that's true. But we could design it differently, right? We could have them forget over time. We could have them kind of learn a space. Part of this is kind of an interesting problem of AI, which is, I can't remember who said it, but someone in the AI community said that it doesn't really matter how smart an AI is, it only matters how dumb it is, because players are willing to kind of believe a lot of a kind of simple AI, but as soon as it makes a stupid mistake, everybody has their kind of immersion broken. So what we want to achieve is something that's sophisticated and interesting, but the biggest thing we want to avoid is kind of stupid mistakes by the AI, like walking into walls over and over. Or anybody who's ever watched Kotaku's highlight reel has seen like bad AI mistakes, and so that's the kind of stuff we're trying to avoid. But yeah, that's a great question. So yeah, I can answer others if people have them, or I can keep talking about.
Yeah, this is another question. Somebody's talking about, was asking about an AI tool called Goblin Ai. I just looked it up. It's a really interesting tool on GitHub.
Oh.
And they're asking if you had any experience using it.
It's called Goblin?
Mm-hmm.
Okay. I guess my ask about the pronunciation suggests no. I have
Yeah.
I've not ever used it. But there are some good tools out there. We specifically needed a utility AI, so we needed one that would do this kind of scoring, because our experience is, at least mine is, that you get a better overall picture of things like animals from a utility AI. You get a more interesting kind of view of them and how they behave. At least things like dogs. If we were doing predators, we might want to do something like a goal-oriented AI. And I'm not sure Goblin with the GO, maybe it is a goal-oriented program. So, like a predator, right? You want them to be able to hunt and sometimes work in packs and kind of circle an animal. Those kinds of behaviors require planning. And so a goal-oriented action planner is a better choice often for things like predators. So cool, good question.
That seems like all the questions we have so far.
Sweet. Well, just to wrap up then, I'll show you, it's not really that different, but here is the AI helper. The AI helper, right from the beginning, knows about everything that's in the room, so knows about all the water bowls and where the sink is. Again, these are choices you can make depending on what you want to happen. The AI helpers have to keep track of how much water they have, and when they run out, they go to the sink, and then they move around and look at water bowls to try to figure out which one to fill up. One thing that's kind of cool about utility over a behavior tree is that you can do things like, let's say this helper has 2 water bowls to fill up, and one of them's like all the way across the room, but there's one really close by. But the close by one is mostly full, right? So think about how humans do this, right? We go, oh, well, I'm right here. I might as well put some more water in this thing before I go all the way across the room to fill that empty one. That's the kind of thing a utility AI will do that a behavior tree won't. Behavior trees can't really be programmed efficiently to do that. So being able to weigh things like, well, this is close, even though it's not quite, empty, I might as well fill it. Those kinds of decisions work pretty, really well in a utility. So thanks for the questions. And I'm going to switch out now to let our next micro talker get involved. Thanks so much, you guys. And I'll stop this little guy. Bye.
All right, everyone. Thanks. We're going to have just a few minutes to roll over and get the next talk set up. Until then, stay posted.
It's Saturday.
Yeah.
It's a less exciting